So the subject of this video will be timber structure. First, we are going to review what we have learned about structure and floor systems. Then we are going to look at how we can produce timber components like posts, beams, and how we can connect them to each other. Of course, we need to learn how to protect timber components and how to create floor systems. So let's remember what we have learned previously. This is the classification of building products. However, we can use that in order to organize our design decisions in the same way. It will be very useful and helpful for us. First, we start designing the building, the whole structure, the geometrical form, the visual aspects, colors, transparency, its position, location, and its relationship with the near surrounding. And based on our decisions in this level, we move on to the units. These are the living spaces for the user. They can be closed, semi-closed, or open areas. And we make decisions about their properties, like their sizes and connections and positions and relationships. And each unit will provide certain functions along with the building itself, the whole envelope itself. The main function is to provide protection and a comfortable life for the user. And these functions and sub-functions, they will be executed by the elements. These are the integral products, and we can create them either by components, like combining components or pieces or materials. And each element will execute one or some of the functions of a building. That's the wall, and this is another element like the roof. And as we place more and more building pieces and components, this will create loads because of the gravity, the vertical loads, also our weights, the weights of the furniture, and some lateral loads like the wind or earthquake. These will affect the building and units in a negative way. So we need one of our elements, that's the building structure. As you remember, it's the system which keeps the form intact. So this is our goal. This is what we have decided for our building. It will hold this. We want that it will hold this shape, this geometrical form, and we need a structure. Otherwise, everything will collapse under all these loads, and so that the structure can meet all the loads, carry them, and transfer them safely to the ground. And it will have components like columns, beams, horizontal components, vertical components, and it will be integrated with the floor systems mostly. Floor is our one of our elements, and it will work for creating living areas for the user. It's the starting point of the load transfer, and it will create the boundary, a horizontal boundary for the spaces. And if there are more than one space, it can provide insulation, separation between these two neighboring spaces. Again, it will have its own components like the floor covering, insulation layers, ceiling covering, and the middle part. It's the floor structure, one of the components of this element. And the first loads are applied firstly on this floor structure, so it needs to be integrated with the beams and the columns, the structural system of the building, so that it will transfer its loads to the beams, and beams can transfer their loads to the columns like that. And previously, we learned how we can create these components, the floor structure, beams, and columns out of concrete and steel. But first, we need to provide a certain shape for this iron material and convert them into steel reinforcement bars. And the combination of these reinforcement bars with the concrete will give us the reinforced concrete as a new material. And by casting concrete on on tightly created reinforcement bar cage, uh, we can have our beams and columns and floor structure. And also we can create all these components out of steel pieces in various shapes. Now, today we are going to learn how we can do these components, the floor structure, beams and columns out of timber. But first, timber, it's the wood, the tree trunk. First, we need to give a definite shape for that and convert it into pieces, create pieces out of that material. That's how we do that. When we cut the tree and get this tree trunk, we move it to a factory or a atelier, and we start cutting that tree trunk into different sized pieces, like that. We saw it into various pieces, and the sewing technique can be different, obviously. We can create different pieces, and we can use them in order to do our beams and columns, the floor structure. Also, based on the sizes and the positions of these pieces, we can use them as covering products like the floor covering or the wall covering, finished products. And like this one, we can have this big middle part and use it as our columns, or the side one can be one of our beams. And the combination will give us the timber structure, timber frame structure. So these are the columns, and that's a beam, and these are the girders, smaller beams. Uh, what is timber and how can we produce necessary components out of that material? Timber is the tree trunk, obviously, and we get mostly this trunk and branch parts, but not the tiny sticks that uh, holds the leaves, or nor the roots. Mostly, 80% of the material comes from trunk and the bigger branches. And it's a fibrous material. When I say fibrous, let's get a closer look to this part here inside of the trunk, and we are going to see these needle-like substances. They are like tiny pipes, and they work for providing water and nutrients for the tree. As you know, in the spring, the roots of the tree they suck sap. That's the name of that mixture. It has moisture, water, and nutrients. It's called sap, and it's like the food for a tree. And the roots start sucking that sap from the soil, and they send that mixture uh, up to the branches and leaves via these pipes, these needle-like smaller tubes. And when they reach the leaves, as you know, in the sap, it has this water moisture, and it gets evaporated, and leaves absorb carbon from air in presence of sunlight, and the sap becomes denser. It becomes denser, and in the atom, the sap descends down, and it's deposited in the form of a layer below the bark. So that's how a tree grows. And the timber, the tree, it should be felled as soon as it's matured. We need to cut it properly as the tree matured in order to have our building material like that. And the best time for cutting the tree is the midsummer or midwinter, because we need to find the time when sap is at rest. As you remember, during the springtime and autumn period, sap is transferred either from below to the upwards, or from the leaves to the bark again, to the trunk again. So in the midsummer, during the midsummer and midwinter, it's in rest. And if it is felt when the sap is vigorous in movement, the timber can decay because it's so moist. And as we cut the tree trunk like that, it's the cross section, and there are certain parts here, like these growth rings. Each year, as the sap goes down, descends down, and deposited as it is deposited behind the bark, a new ring is being formed, and that's how they calculate how old the tree is by counting these growth rings. We have rays. That's the pit, the middle part, the central part. We have bark, uh, and it has two layers. This is the outer bark, and this is the inner bark. And there is this thin part, some sort of a layer in between. That's what is called cambium layer. This part is called sapwood, and that's the hardwood. And as you know, there are two major groups for the trees. The first one is in the endogenous trees, and the other is exogenous trees. Endogenous trees, one of the examples is these um, uh, I forgot the name. Sorry about that. Bamboo. Uh, that's one of the examples for endogenous trees, and they grow endwards. Uh, and you can easily understand it by looking at these notes. The other group is the exogenous trees, and they grow outwards with growth rings each year. And as you can see, as the bamboo tree grows, it becomes thinner, and there will be a bigger void in the center. However, it's not like that with this exogenous trees. It becomes thicker. The trunk part becomes thicker, and we have again two major groups for the exogenous trees. The first group is the conifers, and the other group is the deciduous trees. Conifers, these are the evergreen trees that have pointed needle-like leaves and cones mostly. Sequoia is one of the examples, or fir tree, red cedar, larch pine, different types of pine, spruce, and cypress. These are the most known famous ones, and they are mostly resinous. Resinous, they have this special type of sap, and it's sticky. Uh, in Turkish, we call it reçineli ağaç. And the other group, the deciduous trees, these have different types again, like maple, oak, birch, uh, horse chestnut, and beech, and ash tree. These are some other common types. And we need to pick the right type of tree if we want to create a strong structure, because each type has different properties, and we are looking for tree types which can be durable against insects, microorganisms, water damage, and fire. These are the things that we need to avoid if we are looking for a structural component or material, let's say. And as we cut them into these pieces in definite geometrical forms, like these prisms, we are creating dimensional numbers. This is called the dimensional number now. You know, the growth rings, based on the properties of the tree, the type of the tree, and the conditions that it grows in. It can either have tight grains, very closer, narrow annual rings, or the opposite. And this is the first group, the tight grains. This is what we are looking for the structural material. And also we want high density types of the trees, because these components, once we create components of posts and beams, they will be subjected to these loads that we have already learned like these compression loads for the columns or bending stress for the beams, and the lower part will get tension, and the upper part will get compression stress. If you have durable tree types with tight grains and high density, so it will be better for us to meet and carry all these loads without any risks. And some of the tree types that you can prefer for your project is one of them is elm. It's kara ağaç in Turkish, larch, karaçam, and Calabrian pine, kızılçam. These are the three different options for you to create your structural components. Once we cut the tree trunk, before converting it to the pieces, we need to season it. Seasoning means kurutma in Turkish, because the tree has its moisture, the sap, and it's in a very moisture environment. The air around the tree and the soil, it has so much moisture, and the freshly cut tree looks like that. However, we are going to place it in a very different environment, in a controlled indoor environment where the moisture status is very different from its natural habitat. So first we need to let it dry for a moment, and we can do that naturally uh, with the help of natural air movements. And the only thing that we need is to create some sort of storage. It can be slightly elevated from the moist soil surface, and we can just only cover the upper part to protect it from raindrops. And we place our trunks like that, and they don't touch each other. There are gaps in between, vertically and horizontally, so that air can move freely, and we let it for certain months. But it's hard to control the moisture content, and it depends on the weather conditions and everything. By this way, if it's all go well, we can have the moisture content for these pieces down to 12 or 15 percent. But the better way is doing the seasoning artificially in a kiln. Here you can see a very large chamber, and it's sealed. And there is this dry air, hot and dry air circulated in between these pieces, so we can easily control the moisture level. And even if we get everything perfectly under control, there will be some differences once we place any piece or component in the indoor environment, depending on the function of the unit or the conditions in and around the unit. There can be times where the indoor air moisture is increased, or outdoor air moisture is increased or decreased, or it can have water in liquid form on it, and that will cause the timber pieces to change its form, and that's what we call its shrinkage. In Turkish, we call it ahşap çalışıyor, ahşapın çalışması uh, uh, diyoruz. Here we have these dimension lumbers now, and since they have they have these tiny little pipes, and now they are empty because we seasoned it. The moisture content has been decreased specifically, particularly, and now we have these tiny voids inside these pipes, and there is the humidity in the air that surrounds these dimension lumber pieces or components. And when we say humidity, it's the water vapor in gas form. It's the gas form of water in the air, and these water molecules, gas in the gas form, can build up inside these pipes, or they can leave. There is this constant exchange between the pipes and the air around it. And in Turkish, it's rutubet or nem. Please be aware that it's not the same with mold. Humidity is the water in gas form. Mold is a living organism. It's a type of mushroom. As you know, this is the classical mushroom that we are all familiar with, and it has spores, and once the spores have conditions, appropriate conditions, they start to proliferate, and they create this mycelium, which will turn into a new mushroom. It's something like this, but these mold that's a special type of mushroom, which is very tiny, microscopic, so tiny that we cannot see it with our naked eye. It's something like this, but the system is the same. And these red dots are the mycelium that it has already proliferated all around us. And in order for the mold to proliferate, it needs a moisture environment. So that's why we get confused. Where indoor air humidity is high, especially in dark places, damp places, we get lots of mold because they can have a proper environment for them to grow. So there are different things. We are talking about the humidity, not the mold here. And that water in gas form can build up inside these pipes. And this is the normal timber in its normal humidity percentage. And if it gets lots of humid air inside, trapped inside, then it will change its form. It will swell. And vice versa. If it loses its humidity content, then it will shrink down. Again, it will change its form. And these constant changes may be bad for its properties. It can crack, it can be deformed, and it can lose its load-bearing capacity, abilities. So that's very important for us to pick the right tree, and we need to locate a proper position in order to create our components. This is an image that shows different shrinkage, different types of deformation uh, based on the growth rings. As you can see, if we get a piece out of this pith part, then it will shrink like that. When it loses its moisture content, it will shrink like that. And if the piece is extracted from this part, again, it will have a uniform, mostly uniform shrinkage. Uh, Same almost same like that. However, if we get closer to the bark here or here, as you can see, the deformation is not uniform. It's so much. And this is something that we need to avoid. We are looking for a uniform deformation. So our beams and posts needs to be not from here or here or here. We can prefer the pit or the central parts closer to the pith, not closer to the bark. That's very important for us. And what kind of properties we need to provide for these posts, beams, and how are we going to connect them? That's the material. We saw it, and we have these pieces now. They have a definite geometrical form, and those pieces can be used as components like the columns or posts or beams, these horizontal components or girders. Girders, beams, they are the same girders, only they are the smaller versions of beams in order to support the floor surface. And all of them when we have them in position, all of our posts and beams connecting the posts, that's the timber frame. And let's imagine we can get this middle part, a larger part and a long part. If you have the a big tree trunk, then we can have only one single piece. It's called solid sawn. And there needs to be certain proportions between the length of the post and the width of the post. let's say this is L meters, and that's D centimeters. There needs to be this proportion. L divided by D needs to be smaller than 50. That's important for us. Or instead of this one giant piece, we can have smaller pieces and combine them into these build-up columns, something like this. And we can have these steel pieces and bolts. We can connect them mechanically like that, or they can be spaced like that. There can be a void in between these two pieces. Uh, this will give us more opportunities to create bigger sized columns uh, uh, like that. Or we can have smaller, much smaller pieces, and we can solve them into this jigsaw shape, and we can glue them each other under temperature, under heat and pressure, and create much bigger beams and columns like that. And that's called the glue laminated timber. And if you take a closer look here, there are two neighbor pieces like that. And the first one, it's positioned like this. As you can see, this pith is in that direction. So the growth rings are like this. And the other one, it's positioned in the opposite direction. Its pith is in that other direction. And the growth rings are like that. So when it loses its content, moisture content, it wants to be deformed like that. And the other one will be deformed like that. And they will prevent each other from bigger deformation. They will hold each other. So glue laminated timber is a better option for us. Uh, and same with the beams. Again, I can have this middle part and convert it into one single beam, solid sawn beam. Uh, this is the height of the beam, and that's the width of the beam. Again, there needs to be a proportion between the height and the D and the span. As you remember, span is the açıklık, the distance between two columns. It will be the length of the beam, and we can easily calculate the span based on this rule of thumb. It can be the we get the span, and we can divide the span into 15, and we can find the necessary beam height for us. And D, it can be one third or the half of the H. So these are some formulas that you can use during your school projects. And instead of a solid sawn single piece beam, we can have smaller pieces, and again create these build-up beams, connect them with bolts and metal steel sheets, or we can have these box beams. It can be lighter for us. Again, the glue laminated timber is other option. And even we can create trusses out of these timber pieces, just like we learned how to do in the steel video. The connections they can be created with these metal sheets or profiles, and we can bolt the timber pieces to each other, like two timber beams. We can connect them horizontally, or we can connect the beam with the post like that. The important part is if we have a reinforced concrete or a concrete base, and we are going to place our columns, the posts, we can again have this U-shaped steel sheet, and we can use bolts like that. But these parts, especially in the on the ground floor, they are prone to get wet when it rains, or if the space has this function with the water, and we want to protect it from water damage. So instead of placing it directly on the ground floor surface, we can have this elevated part first, and then we can start our post, we can have our post so that it will be protected from this rain splash. And that will be the better option here because if we have a U-shaped steel piece like this, let's imagine we have this U-shaped steel piece and we place our timber post inside it like that. So this is where our timber post will be, and we are going to connect it with these bolts. And as the raindrops hit here, this surface, they can here like they can stay there, and it can cause the timber post to start decaying from here. So instead of that, if you prefer a connection like this, it will have the chance to dry out without decaying. It will be much better uh, in terms of protecting uh, the timber pieces. So these are the main principles about the connections. Of course, you can design your own connections or search for different types like that. And we need to protect all these components against especially water damage and humidity damage, insects and microorganisms, and fire, obviously. The water and humidity will cause them to decay in time, and that's called wet rot. Or they can have these enormous shrinkages, deformation due to excessive water or humidity or loss of humidity, and that's bad for us. We need to protect our pieces and components out of against these risks. Insects, especially termites, that's the type of an ant, white ants. We don't have them in Turkey, but especially in the United States, this is a major problem, I'm guessing. And there can be some other types. The termites are one of the most famous ones, but there are other types that eats the timber. And from outside, you don't see anything. You just only get these tiny holes, and it looks like there's not such a big problem. However, if you peel the skin of the timber, you will see that there is a damage, a very bad damage, and there is not enough material left. And the fire, I think you remember from our previous videos, timber gets burned, not like steel and concrete. They are not flammable. We cannot burn steel or concrete. However, steel melts, starts to deform, melt down in high temperatures due to fire, and we know that concrete explodes. And because of this deformation, there is the risk of collapsing down, especially when it's on the columns and beams, the structural system. However, as the timber components burn, there is this charcoal layer. It has a thickness, and it acts like a heat barrier. And even if the outer surface gets burned, the stability of the component is protected with this charcoal layer. That means that we have lots of time before the whole structure starts to collapse down, so that we can evacuate the users. This is an image that shows the timber beam. It's still standing, but because of the high temperatures in the fire, these steel beams, they melted and collapsed down. How can we protect it? Same with the steel production, almost same with the steel production uh, protection. We can cover the surface of the timber so that the water or insects or fire cannot penetrate inside those pipe voids. And we can use a brush and certain types of oils. These are called wood preservers. They are essentially chemical substances, or they can be solvents, organic solvents. Or instead of using a brush, we can spray it on the surface of the wood. That means that the exchange between the moisture exchange or humidity exchange or water exchange between the outside environment and the pipes of the timber structure will stop there. And the other method can be is this. This is called full cell or Bethel process. As you can see here, there is a giant tank, and we place all the timber pieces. These are freshly cut and seasoned pieces inside this tank, and we fill it with some sort of chemical. And with the pressure, with the help of the pressure, that chemical will be some sort of injected inside those tiny little pipes, those fibers. Since they are full now, there won't be any water exchange, humidity exchange, and based on the properties of that chemical substance, we can repel insects, or we can uh, extend the fire the burning time. And in Turkish, that's what we call emprunye. It's a French word, obviously, and same with impregnation in English. That's what we are doing. We are impregnating those chemical substances inside these timber voids. There's a video here. Let's watch it together. It explains it in a good way.
Primary preservative treated wood or pressure treated wood. How is it made? Seasoned timber is loaded onto trolleys and then pushed into the treatment cylinder. The door is then closed and sealed. An initial vacuum is introduced to the cylinder by means of a vacuum pump. The vacuum is maintained for a period to extract air from the cylinder as well as the wood cells, making the timber easier to impregnate with a preservative. The cylinder is then flooded with preservative from the working tank, whilst maintaining the initial vacuum until filled. This ensures that there is no air or vapor compressed and trapped at the top of the vessel. After flooding, the vacuum is released and pressure is applied. The pressure is gradually raised to a specific level and maintained until the required amount of preservative has been pumped into the timber from the measuring tank. The amount of preservative is pre-calculated based on the volume of the timber in the cylinder and the hazard class of intended use. The readings are taken from a sight glass or float level attached to the measuring tank. The pressure is then released and the cylinder is emptied by pumping the preservative back into the working tank, where it will create an overflow into the measuring tank. A final vacuum is applied to retrieve excess preservative from the timber, which reduces dripping. When the level indicated on the measuring tank has stabilized, a final reading is taken to verify that the calculated volume of preservative has been retained by the timber. The cylinder door is then opened and the trolley with the pressure treated timber is pushed out to a storage area where it will remain until ready for shipment.
Since it's filled with this chemical substance, there is no void for outside nature, humidity or water to penetrate inside. So that's how we can protect timber components. And based on the type of the chemical, it can protect it from fire damage and repel insects, as I told you previously. Now, let's take a look how we can create the floors. As you know, these are the posts, and we connect them with beams. And now we want to create a horizontal surface for us to live our lives on. And we need to fill all these gaps somehow. We can use boards. These are large but very thin boards, and we can get lots of them. We want to place them next to each other in order to create that horizontal surface. However, since the void, the inner part is so large, they won't there's nothing to support them. They will just fall down. That's where we can use the girders, the smaller beams. We can divide that void by using girders, smaller beams, so that when we place our boards, they will be supported, they won't fall down, and we can cover the whole surface to create our floor. So something like this. And for the boards, we can use engineered timber panels. These are thin but large panels, and there are different types. This is called plywood. In Turkish, we call it kontrplak or katmanlı ahşap levha. And as you can see, it's created with a very thin, like millimeter or 1 millimeter, 3 millimeter thick natural wood panels, and they are positioned in the opposite directions, like just like we examined in the glue laminated timber. Its load-bearing capacity, the plywood's load-bearing capacity, it's good. Its durability against water and negative conditions, it's again good. And this is how they do that. We have the tree trunk. This is how they are created. They get this tree trunk. First, they debark it, and then they peel it into these very tiny, very thin sheets. Not tiny, very thin sheets, but large. And they are flexible, and we just get lots of these sheets in different thicknesses, like 1 millimeter, 3 millimeters, 5 millimeters, and we place them on top of each other, and we apply pressure and glue them together so that we can get this thicker panels. And generally, it's like 3 meters and 1 meter or 1.5 meter. The thickness can be like 2 centimeters, 5 centimeters. There are different options in the market. When they are processing wood, there can be little tiny chips left behind, and normally they are just going to be thrown out. However, they get them and they collect them, and again, with the help of some sort of synthetic resin binder, they create these chipboards. As you can see, it looks like one single object. However, there are many little tiny chips, and they are just glued together under pressure and heat. Sentetik reçine bağlayıcılı resin, but not the natural resin. Some sort of plastic created in a factory environment, and it's used to bind these chip particles. In Turkish, it's called sunta. However, its load-bearing capacity is not good. Its durability against the negative conditions is not good. It can be affected negatively, especially against water damage. This is something that we use for our furniture mostly. All of our cupboards and tables and sofas, they include chipboard because they will be in a dry environment all the time. There's no water damage risk. However, if there's a flood and your furniture stays in the water for a significant amount of time, they start to dissolve. That synthetic resin is a substance that can be dissolved in water, and you get these dust-like chips left. Structurally, it's not advised to use chipboard. And the other option is this oriented strand board, yönlendirilmiş talaş levha, or OSB. We say OSB, oriented OSB in Turkish. Its load bearing capacity is good. Its durability against water is not that bad with the chipboard, like the chipboard, but not as strong as the plywood. It's something in between. And if we, instead of that synthetic resin binder, if you get cement to bind these particles, again, we can create a chipboard, but this time it's with a cement binder. In Turkish, it's called Heraklit. That's the name of the brand that first introduced that product to the market. And it's since it has cement in it, it's very, very strong and very durable against negative conditions. And the last option, the fifth one, is the fiberboard, lif levha in Turkish. However, we know it mostly MDF or HDF, middle density fiberboard, high density fiberboard. There are different options. The density, it implies the amount of particles and its durability, obviously. And again, it has a good load bearing capacity and good strength against all these negative conditions. So we have these five options. The best ones can be plywood and HDF, HDF, high density fiberboard, or cement chipboard. We need to avoid that one, the synthetic binder chipboard, Sunta. We don't want that. And again, we can use oriented strand board as well for our floor surface, and we can have one or two layers on top of each other. Each will be supported with these girders. And as you know, these are the boards that are used in creating our furniture, all of them, especially. They mostly prefer that because it's lightweight and it's cheaper than the others. However, when we look at our tables and cupboards, we don't see that texture because it's hidden under the actual very thin veneers. It's called veneers, and they have only 1 millimeter or 2 millimeter thicknesses, very, very thin, even maybe half millimeter. And these are used to cover the surfaces of these panels, or we can just dye them, paint them, or cover them with plastic substances, surfaces. And this veneer is created like that. There is a saw, a special saw, and it peels the tree trunk like that. These are the chips that to create that chipboard and cement binder chipboard or oriented strand board or that fiberboard. These chips. So they debark the tree from. As you can see, it's same with same procedure with the creating that plywood panels. However, these are thicker and these are very thin, thinner than 1 millimeter. It's like paper, and they are just natural wood. And these veneers, they are called veneers. They are used to cover the surface of these engineered wood panels. So it's that. And with this, we learn how to do the timber flooring systems. And hopefully, in our next video, we are going to do our third element, third building element. The first one was the structure, the second one was the uh, floor, and now we are going to move on to foundations. Okay, see you.